Hello, students, and welcome. Today, we are going to understand a very important concept in chemistry, and we will make it feel simple and very easy to remember.
So let us start with a question from our own kitchens. You must have seen that when we cook pasta or boil potatoes, we often add salt to the water. This actually makes the water hotter and helps the food cook faster. But why does this happen? Well, the answer to this everyday mystery is a core concept in chemistry, the vapor pressure of liquid solutions. Okay, so let's dive into this topic properly. Now, understanding this concept is absolutely crucial. It is the foundation for explaining why solutions behave so differently from pure liquids, especially when we talk about boiling and freezing.
At the most simple level, just imagine a liquid in a closed bottle. Some molecules at the surface will have enough energy to escape into the space above, and they become a gas, or what we call a vapor. This vapor, it creates a pressure.
So in this closed system, a state of equilibrium is reached. The rate of evaporation becomes equal to the rate of condensation. The pressure at this specific point is what we call the vapor pressure.
Now here is where it gets really interesting. What happens when we dissolve something like salt, which is a non-volatile solute, into the liquid? Well, the vapor pressure goes down. It decreases.
And this is a very crucial point, so listen carefully. Many students think that if you add more stuff to a liquid, it should increase its pressure. But for vapor pressure, the exact opposite is true. The solute particles actually get in the way. They block the surface, and so the pressure decreases. To make this idea very, very clear, let us use a simple analogy. I want you to imagine a crowded party. This party is our liquid. The guests who are trying to leave the party represent evaporation, and there is only a single doorway to leave. This is the liquid's surface. Now, what if someone just stands in the doorway, blocking the path? Of course, fewer people can get out. The solute particles, they act exactly like this obstacle, reducing the rate of evaporation. You know, chemists developed this whole idea to solve a very fundamental problem. Why does salt water boil at a temperature above 100 degrees Celsius? Understanding vapor pressure was the key to this question.
Okay, now let's zoom in a bit and see what is really happening at the molecular level.
In a pure solvent like plain water, the entire surface is occupied only by water molecules. So those molecules that have enough energy are free to escape into the vapor phase. This leads to a high rate of evaporation. But now we add a non-volatile solute. Its particles get mixed in and they start to take up space at the surface, which is exactly where the evaporation happens. So you see, these solute particles, they act like blockades. They reduce the effective surface area that is available for the solvent molecules to escape from. And because the rate of escape is now lower, the pressure of the vapor above the liquid will also be lower when the new equilibrium is established. This picture, it perfectly illustrates the core idea. This relationship is described formally by Raoult's law, which is a very, very important formula for your exams. It helps us calculate the new, lower vapor pressure of the solution. It is the mathematical key that lets us predict exactly how properties like the boiling point will change.
So how does all of this connect back to our daily life and to technology?
Well, a liquid boils only when its vapor pressure becomes equal to the atmospheric pressure. Since salt water has a lower vapor pressure to begin with, we must heat it to a higher temperature to make its vapor pressure rise enough to match the atmosphere's pressure. Only then will it boil.
This very same principle is used in large-scale technology, like desalination. In a process called reverse osmosis, plants apply extremely high pressure to the salt water. This huge pressure overcomes the natural tendency, and it forces pure water molecules through a special membrane, leaving all the salt behind. This is a direct, life-saving application of these vapor pressure principles.
All right, let's just quickly recap the most important points from this explainer. Please remember, the core idea is that solute particles simply get in the way of evaporation. Just think of the party doorway analogy. This one simple fact explains why adding salt to water raises its boiling point.
I want to encourage you all, if you can just remember this one core idea, that mental picture of particles blocking the surface, and the real-world example of boiling pasta, I promise you, you will find this topic much easier to handle in your exam. And to leave you with a final thought, we have seen that lowering the vapor pressure makes it harder for a liquid to boil. So, what effect do you think this same principle has on making a liquid freeze?
We will explore that question in our next explainer on colligative properties.